In this lecture, we will learn what a collection is and the different types of collections supported by the Python programming language. A collection is something we use in computer programming to store multiple values. Whereas a data type stores only one value, a collection can hold many values that we can work with in the program. Python supports four main collection types: lists, tuples, dictionaries, and sets. A list is an ordered collection of data. A tuple is an ordered, unchangeable collection of data. A dictionary is a collection of key-value pairs, and a set is an unordered collection of data that does not contain any duplicates. If you're familiar with another programming language like Java or C#, you may be wondering, what about the array data type? A list in Python is the equivalent of an array in other programming languages. Also, what about the stack and queue collection types? While Python doesn't contain a built-in stack or queue collection type, it does give us the ability to implement our own using its built-in types. Now that we understand a bit more about collections, let's learn about each collection in depth in the coming videos. In the next lecture, we will learn about lists and how to work with lists in Python. In this lecture, we will learn about what lists are and how to work with them in Python. What is a list? Put simply, a list is an ordered collection of data. If you are familiar with other programming languages, lists are the Python equivalent of arrays. Let's take a look at a basic example first. We will create a variable named collection and set it equal to a list with the elements 1, 2, and 3. If we want to see how many elements are currently in our list, we can use the len function. For example, we will call the len function on our collection list and print it to the console. Let's say we want to grab one of the values out of the list. To keep it simple, let's try to grab the first element from our list, the 1. We can do this by what is called indexing. In programming, ordered collections like lists have a concept called indexing, meaning that each of their elements is stored at a specific, numbered position in the collection. Indexing starts at 0. In our list, we would say element 1 is at index 0, element 2 is at index 1, and element 3 is at index 2. When we want to get an element at a certain index, we first type the name of the list, which is collection in this case. Then we use square brackets, inside of which go the index of the element we want to access. For example, we want to access the element at index 0. When we run the code, you will notice that 1 was printed to the console. If we change the index to 1 and run the code, you will notice that 2 was printed to the console. And by that same logic, changing the index to index 2 and running the code will result in 3 being printed to the console. One common mistake of beginner programmers is that they forget that indexing starts at 0, and they end up using index 1 to try to reference the first element in the list. There is another way to reference elements, and that is by using negative indexing. Negative indexing starts at the end of the list and begins at index -1. For example, we can print out collection at -1, and we will see that 3 was output to the console. If we want to access the 2 in our list, then we could do so using index -2. If we change the index we are referencing to -2 and then run the code, you will notice that 2 is output. By now I think you get the idea. Obviously we could access element 1 with index -3, but I won't bore you with that example. We can also use a range of indices when working with lists. For example, let's say we want to grab the first 2 elements in our list. The way that we do that is as follows. We start out with the name of the list and square brackets, just like before. Then comes the starting index. We want to start out with index 0. After that comes a colon, then the end index, which is exclusive. This means that the sublist we get will include the elements up to 1 less than this index. So since we want to just grab the elements 1 and 2, we specify the index 2, since the program will then grab the elements at indices 0 and 1, but not 2. Remember, the ending value is exclusive, not inclusive. We can also choose not to specify a start or end value in this scenario. If we don't specify a starting value, then it will automatically start at the beginning of our list. For example, removing the starting value of 0 will have the same effect as our current code. When we run the code, notice that the sublist output to the console contains the elements 1 and 2. We can also omit the end value, which means that the sublist will go to the end of the list. For example, removing the 2 and running the code will result in the whole list being output as the sublist we grabbed using this technique. What if we want to change the value of an item in the list? We can do so using its index. For example, let's say we wanted to change the value 3 in our list to 4. First, we will reference collection at index 2, which is the position of the value 3 in the list, and then we will use the equal sign to set it to 4. Next, we will print out the value of collection at index 2. When we run the code, you will notice that 4 was printed, meaning our code worked. Let's learn how to loop through all of the items in a list. We call this iterating over the items in a list. To accomplish this, we can use a for loop. The first step is to type for I in range and then pass in the len function, and then the collection. This tells Python to create a variable I, known as an iterator variable, and then to execute the for loop the amount of times of elements in the collection. On each iteration, I will change its value to be the element in the collection that it is currently on. Inside of the for loop, we will print out collection at index I. When we run the code, you will notice that the values 1, 2, and 3 were printed out. On the first iteration of the for loop, we start at the beginning of our list. The first item in our list is 1, so I becomes 1, and then we print out 1 to the console. Then the second iteration happens. The second list item is 2, so 2 gets printed out to the console. Finally comes the third iteration. On that iteration, the value of I is 3, so 3 is printed to the console. What if we wanted to check if an item is in the list? How would we go about doing that? We could combine the concepts of an if statement and Python's in keyword to achieve the desired effect. We start out with an if statement and say if 1 in collection. This will check if the element 1 is present in our collection. If this is true, we will print the phrase 1 is in the list to the console. Else, we will print the phrase 1 is not in the list to the console. When we run the code, you will notice that the if statement evaluated to true because 1 is in the list, and the phrase 1 is in the list was output to the console. Now that we have a general understanding of how to work with lists in Python, let's learn about the different functions we can use on lists. If we want to add an element to the end of the list, we can use the append function. For example, let's use Python's append function to add the element 4 to the end of our list. Then we will use Python's print function to print our list to the console. To remove all of the elements in a list, we can use the clear function. We will use the clear function on our collection list, and then print out collection to the console. When we run the code, you will notice that our list is now empty. Let's actually intentionally put the list elements out of order for this next example. We will make the order of the elements 2, 3, and 1. To sort the elements of a list in Python, we can use the sort function. For example, let's call the sort function on our list, and then print it to the console. When we run the code, you will notice that the list was sorted. To reverse a list, we can use Python's reverse function. When we run the code, you will notice that the list was printed with the elements in reverse order. Let's say that we want to count how many times the element 2 appears in the list. To do this, we can use Python's count function. We will print out the result of a call to collection.count and pass in 2. When we run the code, you will notice that 1 was printed to the console. This makes sense since there is one instance of the element 2 in the list. We can combine two lists by using the extend function. First, we will create another list named collection2 and assign it a list with the values 4, 5, and 6. Then we can combine the two lists by doing collection.extend and then passing in collection2 inside of the parentheses. Then we will print out collection to the console. When we run the code, you will notice that collection not only contains its original elements, but also contains all of the elements from collection2. We already looked at how we can retrieve an element by its index, but what if we wanted to retrieve the index of an element? To do this, we can use Python's index function. For example, we can find the index of the item 2 in the list by calling the item function on our collection list and passing in 2. When we run the code, you will notice that 1 was printed since the index of element 2 in our collection list is 1. To insert an item into our list, we can make use of Python's insert function. For example, if we want to insert the element 9 into our list at index 0, we will call collection.insert and pass in 0 as the first argument and 9 as the second argument. Let's also print the collection to the console. When we run the code, you will notice that 9 was added as the first element of our list, thanks to the insert function. Now we know how to add items into a list, but what happens if we want to remove items? To do this, we can use Python's pop and remove functions. If we want to remove an item at a certain index, we can use the pop function. For example, we can pop the element at index 0. When we run the code, you will notice that the first element was removed from the list. Python's remove function allows us to remove an element from a list by its value. For example, if we want to remove the element 1 from our list, we can use the remove function and pass in 1. When we run the code, you will notice that the element 1 is no longer in our list. It is important to take note that you can have items of different types in Python lists. It is perfectly valid for us to have a list that contains a string, integer, bool, or even another list. Lists are one of the most important and most used collections in Python. In the next lecture, we will learn what tuples are and how to work with them in Python. In this lecture, we will learn what tuples are and how to work with them in Python. A tuple, like a list, is an ordered collection. However, unlike lists, tuples are unchangeable. This means that once we create a tuple, we cannot change or modify it. Remember how lists used square brackets and separated their values by commas? Tuples are similar, but use parentheses instead of square brackets. As a basic example for creating a tuple in Python, we can create a variable named collection and set it equal to a tuple with the values 1, 2, and 3. Indexing with tuples works the same way as it did for lists. For example, we can print out collection at index 0 and run the code, and you will notice that 1 was printed to the console. Negative indexing is also the same. If we print out the result of collection at index -1 and run the code, you will notice that 3 was printed to the console. Please note that tuples are immutable or unchangeable. We cannot use indexing to set an element in a tuple to a new value. For example, attempting to change the element at index 0 to 4 and then running the code will result in an error. The specific error is a type error, informing us that the tuple object does not support item assignment. However, there is a workaround for changing values in tuples. Basically, we convert the tuple to a list, change the value, and then convert it back to a tuple. The first step is to create another variable and convert our tuple to a list. I will create a variable named collection2 and set it equal to collection converted to a list. Then we change the value that we want to change. In this case, I will change the element at index 0 to 4. Then we set our original collection variable equal to collection2, converted back to a tuple. And finally, we print out the collection to the console to see the result. When we run the code, you will notice that the first element of our tuple is now a 4 instead of a 1, proving that our code works. Please note that since tuples cannot be changed, we cannot add items to a tuple. This will raise an error and is invalid in Python code. To loop over the elements in a tuple, we can use a for loop. For example, we will say for I in collection, and inside of the for loop we will print I. When we run the code, you will notice that each of the elements was printed to the console as a result of the for loop. To check if an item exists in the tuple, we can use the in keyword. For example, if 2 is in the tuple, we will print 2 is in tuple to the console. When we run the code, you will notice that 2 is in fact in the collection, since the statement was output to the console. We can join two tuples together using the plus operator. For this example, we will create a variable named collection2 and assign it a tuple with the values 4, 5, and 6. Then we will use Python's print function and pass in collection plus collection2. When we run the code, you will notice two tuples were joined together into one big tuple. To count how many times an element occurs in the tuple, we can use the count function. For example, we will print out the result of collection.count and pass 1 into the count function to count the number of times that 1 occurs in the tuple. When we run the code, you will notice that 1 was printed since the element 1 occurs once in our tuple. The index function will return the position of the specified value in our tuple. For example, we can print out the result of collection.index and pass in 1 to the index function to obtain the index of element 1 in our tuple. When we run the code, you will notice that 0 was printed since the index of element 1 in our tuple is 0. In the next lecture, we will learn what dictionaries are and how to work with them in Python. In this lecture, we will learn what dictionaries are and how to work with them in Python. A dictionary is an unordered collection of key-value pairs. To create a dictionary, we can start out by using the dictionary constructor, typing dict, and then a pair of opening and closing parentheses. Next, we're going to add some key-value pairs to our dictionary. To do this, we type the name of our dictionary, which is collection in this case. Then we use a pair of square brackets, inside of which goes the name of the key. A key has to be an immutable type, like a string, and we cannot have duplicate keys in our dictionary. I will make the key name key1. We will set this equal to the value for this key. In this case, the value will be a string named value1. Let's add a few more key value pairs to our dictionary. Our next key value pair will be the strings key2 and value2. Then let's add another key value pair with the strings key3 and value3. Now, there is another way that we could have created our dictionary. Let's illustrate this by first creating another variable named collection2 and assigning it a pair of opening and closing curly braces. Then we will add our first key value pair. On the left comes the key, then a colon, and then the value. Then we will add a comma. In dictionaries, key value pairs are separated by commas. Then will come our next key value pair, which is the strings key2 and value2 respectively. Then will come another comma, and finally the third key value pair. Dictionaries rely on the concept of hashing. Hashing basically means that instead of objects being ordered by index, as they are with lists and tuples, each item of the dictionary is associated with a key. Instead of relying on an index, we use the key to retrieve the value. If one list has 10 values and another has 10,000 values, it will take longer to search for a value from the second list, the longer one, than the first. We would need to go through each value, looking for the item that we are seeking. However, thanks to hashing, finding an item in a dictionary with 10 elements versus a dictionary with 10,000 elements takes the exact same time. Let's take a look at some of the different functions we have available to us when working with dictionaries in Python. To clear all of the items from a dictionary, we can use the clear function. To retrieve a value from a dictionary, we can use Python's get function. For example, let's say we wanted to retrieve the value of key1 in the dictionary. We will print the result of calling the get function on collection2 and passing in key1. When we run the code, you will notice that value 1 was output to the console. To remove a key value pair from the dictionary, we can use the pop function. For example, let's say we want to remove key1 and its associated value, value1, from the dictionary. First, we will call the pop function on our collection2 variable and pass in key1. Then we will print out our collection2 variable to the console to see the result of the code we just wrote. When we run the code, you will notice that the first key value pair that was in our dictionary was properly removed. Even though dictionaries are unordered, we can use iteration, for example, with a for loop, to iterate over all of its keys or all of its values. For example, say we want to print each of the keys in our dictionary to the console. First, we start out with a for loop for I in collection2.keys. Keys is a function Python gives us that allows us to group all of the keys for the dictionary. Inside of the for loop, we will print I. When we run the code, you will notice that the keys key1, key2, and key3 were printed to the console. Changing the keys function to be the values function and running the code will result in each of the values being printed to the console. That is an overview of dictionaries, what they are, and how to work with them in Python. In the next lecture, we will learn what sets are and how to work with them in Python. In this lecture, we will learn what sets are and how to work with them in Python. A set is an unordered collection of elements that does not contain any duplicates. Set elements are contained inside of curly braces. We mainly use sets when we want to make sure that our collection does not contain any duplicate elements. To start, let's create a variable named collection and assign it to a set containing the elements A, B, and C. Note the syntax. The set is inside of curly braces, and just like most of the collections we have learned about, each element is separated by a comma. To add an element to a set, we can use the add function. We will type collection.add and pass in D to add the element D to the end of our set. Then we will use Python's print function to output the collection to the console. When we run the code, you will notice that our set now contains 4 elements, A, B, C, and D. If we want to remove all of the items from a set, we can use the clear function. For example, we will type collection.clear and then print out the length of our set. When we run the code, you will notice that 0 was printed, since all of the elements were removed from the set. To remove a specific element from a set, we can use the discard function. For example, let's call the discard function on our set and pass in the string A to remove this string from the set. Then we will print out the collection to the console. When we run the code, you will notice that the set contains the elements B and C, but no longer the element A. This is because we discarded that element from the set. To remove a random element from the set, we can use the pop function. This function will simply remove one element at random out of the current elements in our set. For example, let's call the pop function on our collection and then print out the collection to the console. When we run the code, you will notice that one of the elements was removed from the set. For these next examples, let's create a variable named collection2 and assign it a set with the values C, D, and E. If we want to see which elements are in one set or the other, but not both, we can use the difference function. We will print out the result of collection.difference and pass in collection2. When we run the code, you will notice that the elements A and B were printed, since these are the elements in collection that are not also in collection2. The intersection function allows us to retrieve the elements that are common to both sets. For example, let's print out the result of collection.intersection collection2 and then run the code. As you can see, a set containing the element C was printed, since C is the only element common to both sets. We can also combine two sets into one using Python's union function. For example, let's print the result of collection.union collection2. When we run the code, you will notice that we get a set that contains the elements of both collection and collection2, with no duplicate C, of course, since even though C is present in both sets, a set cannot contain duplicate elements. When working with the set data structure, two terms you will come across are subset and superset. A subset is a smaller set that has elements in the larger set. A superset is a set whose elements appear in a smaller set. Python gives us the isSubset and isSuperset functions to determine whether sets are subsets or supersets of each other. For this next example, we are going to assign our collection2 variable a set with the elements A and B. Then we will print the result of collection2.isSubset and pass in collection. When we run the code, you will notice that true was printed, since collection2 contains the elements A and B, both of which appear in the collection. Since collection2's elements appear inside of the collection, we say that collection2 is a subset of collection. Similarly, we can use the isSuperset function to determine if one set is the superset of another set. For example, we can print the result of collection2.isSuperset and pass in collection. When we run the code, you will notice that false was printed, since collection2 is not a superset of collection1. In the next lecture, we will learn about Python's none type. In this lecture, we will learn about Python's none type. If you've programmed in a language other than Python before, like Java, C# or C++, you are most likely familiar with the concept of null. Null means that an object or variable doesn't contain a value. Python's version of null is none. It is basically the same as null, but with a few key differences. None is its own object. In Python, a function that does not contain a return statement returns none. None is an immutable keyword in Python, just like the true and false Boolean keywords. When we check for none, we want to use identity operators like is and not, as opposed to equality operators like the double equals sign or the not equals operator. For example, if we had a variable named x set equal to none, and we wanted to check if x is none, we would want to use the is keyword to do if x is none. We would not want to do the if x equals none. In fact, PyCharm recognizes the double equal sign should not be used in this context and underlines it with a yellow line. Right-clicking on the line and selecting Show Context Actions allows us to refactor it to use the is syntax. In the next lecture, we will look at a recap of what we learned in this section of the course. In this lecture, we will look at a recap of what we learned in this section of the course. This section was all about the built-in types, data structures, and collections that Python gives us access to. First, we learned about the fundamental types that Python supports: strings, integers, floating points, and booleans. Then we learned about some of the built-in collections supported by the language: list, tuple, dictionary, and set. If you've worked in other languages before, you're probably familiar with some of these types and collections. We also learned about the none value that Python supports. When programming, it is especially important that you make good choices for which data structures and collections you use in the programs that you write. Doing so could have a big impact on the performance of your code. As you gain more experience working with each of the data structures and collections, you will have a deeper understanding of each and understand better when to use each of them.